if you notice that first group of problems on page 55, it says find the exact expressions for the sine, cosine, and tangent. Page 50. And would be problem 4. It's given us a and it says that that little square thing means it's a right angle right there. And then it's listing these things out. This is A. That's that point, and that'll be that angle. And then they're saying Z, Y, and K. And then they want to know sine of A. What you want to use is sine is going, this is the angle, and sine is opposite over hypotenuse. So and so that's going to be K over Z. Cosine, what are the words that we use for the cosine of the angle? Adjacent over hypotenuse. And the adjacent is going to be Y over Z. And then the tangent of the angle is what? Opposite over adjacent. So K over Y. And this is what you want to memorize those things. The angle, and this is for right triangle trig, and it's in a right triangle. It's not just in any triangle, it has to be a right triangle. And then these relationships apply for the two acute angles, because there's no, you can't do it for this 90-degree angle. It's only for the two acute angles that those words apply. Now that next, the concept thing says, for each trig function in column 1, choose its value from column 2. And let's just go around. If you look at the previous page there on 54, you pick it up there. The thing that I'm suggesting that you do, because is memorize this, is that if you get the sine, and if you go 30 degrees, 45 degrees, 60, 90, and I'll go 0 here. And if you say the sine of 0 degrees is always 0. 30 degrees is 1/2. 45 degrees, square root of 2 over 2. 60 degrees is the square root of 3 over 2. And then this is 1. And if you go cosine, and this just goes backwards. It'll just be, this will be first. So it'll be cosine of 0 degrees is 1. Cosine of 30 degrees, the cos is its cofunction, right? So 30 degrees, cofunction of that is sine, and sine is 90 minus 30 and 60. So it's this one. Square root of 3 over 2, and then it's the square root of 2 over 2. and then it's 1/2, and then it goes to 0. Now, if you basically know those two, then what can you do when you go to tangent? Tangent, you can just use your identities, which is what? Sine over cosine, correct? And then cotangent, in terms of sine and cosine, is going to be what? Cosine over sine, right? See what I'm doing? I'm just using identity. Everyone see? James, do you see?
No. How did you, I'm just the connection.
Well, tangent, if you remember that, if you go back to the coordinate thing, the sine was y over r, the cosine was x over r. So then the tangent was y over x, but that's just, if you take the sine, which is y over r, over the cosine, which is x over r, you invert that, then it's y over x. That's what, this is an identity. Sine, tangent is equal to sine over cosine is an identity. And then because tangent is equal to 1 over cotangent, or cotangent is 1 over tangent, then it's just the invert of this. And what I'm showing you is that once you know these, then all of these are calculable. Tangent is, cotangent is. Secant is going to be what? In terms of these two. Is what? 1 over cosine. And cosecant is 1 over sine. You see, if I know these are 30, 45, and 60 are the important angles. 0 and 90 are also important. So if you know these, and all you have to do is know that sine starts at 0 and it goes 1/2 square root of 2 over 2 square root of 3 over 2 and 1, and cosine just goes the other way around. It goes from 1 down to that in that order. Then you can calculate tangent because the identity says you put this one over this one, right? For each one of those different angles. You guys seeing it?
Yeah, I just don't remember a lot of the relationships.
Yeah.
But yeah, that's what you're kind of.
Yeah. So my point is that you see that what I've done, I know sine and cosine because that I've taught it. I don't know off the top of my head what the tangent of 30 degrees is, but I know what sine and cosine is off the top of my head. So if I need to know what tangent of 30 degrees is, I just say, well, it's sine over cosine, and sine I know is this, and cosine's that, and therefore I can. Then I don't have to remember. Do you see this table here on 54? See, they have sine, cosine, tangent, cotangent, secant, and cosecant. I'm just saying all you got to know is sine and cosine. You can calculate all the rest of that by just knowing identities. But do you understand what I'm saying? So, and these two are the important ones, the sine and cosine. So let's just look at it. Let's just go around the room. Chris Sharp, tell me number 5, and you can look at the table. Tell me what sine of 30 degrees is. Okay. Or if you want to, you can go up here and look at this thing. So let's see, Devin, cosine of 45 degrees. Okay. Then we'll go to Chris Sharp, tangent of 45. Okay. So then you can see up here it's sine, it's just square root of 2 over 2 or square root of 2 over 2, it's 1, right? So if you just knew this, you could easily figure that out. then the secant is 60 degrees. And you can use the chart, or you can think of it as secant. What's the relationship that I've shown you for secant? 1 over cosine. So if you just knew this, what I have written up there, you can calculate it. Or if you have the table, you can look at the table and get it off. What? Okay. So let's see. Lucas, what is number 9? Cosecant of 60. Okay, you'd have to invert multiply, right? And here's the trick when you're looking at number 9 cosecant, you know that it's one of those inverts. It's 1 over sine or 1 over cosine. And every time I see it, I'm always prone to say it's 1 over cosine, because cosecant seems like it should be 1 over cosine, but it's actually 1 over sine, right? And secant is 1 over cosine. It just the way the words are. Does it suggest to you the way the words are that you'd kind of think cosecant should
Some better words when they make more sense.
Yeah, but they're co-functions. Secant and cosecant are co-functions of each other. But what it is the cosecant is 1 over sine. Do you understand what I'm saying? Is that whenever I see cosecant, I always have to stop and say, I know it isn't 1 over cosine, because that's what's logical. It's 1 over sine. But you can look at the table and you can see what the cosecant of 60 is. Cotangent, Greg, what is that of 30? Okay. Saying if you use the thing that I'm saying, 60 degrees, you would have this in the numerator, that in the denominator, and then you'd have 1 over the square root of 3. That you'd have to rationalize that denominator, right? And remember, don't leave it as an unrationalized denominator. Okay. Now remember those cofunction things, sine, and which of the two, sine and what, are cofunctions? Sine and cosine are cofunctions. So this is what a cofunction is. If you have the sine of theta, then it's the same as the cosine of 90 degrees minus theta. You see that? If I have the sine of 30 degrees, then 90 minus 30 is what? 60, isn't it? And you see it's the same thing as the cosine of 90 minus 30. You see that? That's what cofunctions are of each other. So if you have the cosine of 30 degrees, that's this, well then it's the same as the sine of what? 60. 90 minus 30. Cofunctions are something that if you take 90 minus whatever angle you have, it'll be the same number as what you have there. That's the definition of a cofunction. That complement, 90 minus an angle is a complement of that angle. So cofunction, you have a cofunction, you have the sine of an angle, it's the cosine of its complement. And tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. So it's always, whatever you have, you take its cofunction and go 90 minus it, and they're going to be the same. And it don't make any difference. You know, these are just special angles, 30, 45, and 60. But it's any angle, acute angle. You know, obviously, if you don't have an acute angle, you can't get a complement of an acute angle. I mean, of an obtuse angle. Correct? Obtuse angle is something that's greater than 90. Well, there's no such thing as a complement of an obtuse angle. That'd be a negative, right? It'd be 90 minus 120 is going to be a minus 30. Well, they're not complements of each other. All right. Now, it just says in this next group of problems, ABC is a right triangle with sides A and B and C, and the right angle is at C. Typically, that's what it's always going to be, is that the right angle is always going to be C. Then find the values of the 6 trigonometric functions for angle B. So this is going to be actual values. I don't know. Note number 12. Now that is going to be you have two sides. No, that isn't going to be what I was going to tell you what it was, but it isn't. A is 3, B is 5. So what we have to do is we have to calculate what C is, right? Because this is what we have, to put it in proportion, this one is longer than this one. So I'd have to have I'd have to have point A there. This is going to be little a. C is going to be here, which I don't know. And that's a right angle, right? Because they're saying that you have ABC and it's a right triangle. So that's what it has to lay out. And this is relatively in proportion. This is the shorter side, and this is the longer. So what we have to do with this, in order to get the trig functions, it says, which angle? Find the unknown length of the Pythagorean theorem, and then find the values of 6 trigonometric functions of angle B. All right. So what we're going to have to do is, how do we calculate C? No. See, when we have these sides given, it's A squared plus B squared equals C squared, right? And then it's going to be a positive. It's plus or minus when I take, you know, what I'm doing is I'm doing this. C squared equals A squared plus B squared. That's a Pythagorean theorem. The sum of the squares of the sides is equal to the square of the hypotenuse. So in C is going to be the positive of that. So then it's 5 squared plus 3 squared. It's going to be the square root of 25 plus 9 square root of 34. Did I do that right? And nothing comes out from underneath that square root of 34. No, I'm not going to, I guess I'll do all 6 of them. Sine of B. Now the sine of B is going to be what? Opposite over hypotenuse, and this is square root of 34. So do you want me to write opposite over hypotenuse, or will we just put the numbers there? If you go back and look at it, will you? I'll put it this way. Opposite over hypotenuse, which is going to be 5 over the square root of 34. Now, what do I have to do with that? I got to rationalize the denominator. So I'm going to go square root of 34, square root of 34. Then my answer is going to be 5 square root of 34 over 34. So the cosine of B is going to be what? Adjacent over hypotenuse. And the adjacent is 3, excuse me, over the square root of 34. And I have to do what again? Rationalize the denominator, right? So my answer is going to be 3 square root of 34 over 34. Now the tangent B is going to be opposite over adjacent. The opposite is 5 over 3. Now we don't care about improper fractions, we just leave it that way. Now then, the next trigonometric function, I want to write the one that's related to sine. So which one is it? Cosecant of B. Now that's going to be hypotenuse over opposite. And so it's just the invert of this, so it's square root of 34 over 5. And I don't have to do anything with that, correct? Now, I want to do, what's the one that's the inverse that's related to cosine? Secant. And that's going to be hypotenuse over adjacent. And that's going to be the square root of 34 over 3. And then the invert on the tangent, cotangent. And that's adjacent over opposite. And it's the invert here, so that's 3/5. So that's what you do. All right, the next group of problems, it says write each function in terms of its cofunction. So let's look at 20. It says the sine of 27 degrees. Well, what's the cofunction of sine? Cosine. Cosine. Yeah. It's the cosine of 90 degrees minus the 27 degrees, which is equal to the cosine of, what, 63? Remember, the cofunction, sine and cos. See, when you talk about inverts, the inverts, that's secant, like the invert of the sine, cosecant is the invert of the sine. But the cofunction of sine is cosine. They're different, they mean different things. Now let's look at 22. It says cosine of alpha plus 20 degrees. Well, what's the cofunction of cosine? Sine, right? And then it's 90 degrees minus the quantity alpha, not infinity, plus 20. So this is going to be the sine. Now notice that this negative changes both of these signs. This is a negative 20, so that's 90 minus 20 is 70 degrees minus alpha. So this is the cofunction of cosine. And then next group, any questions on that part?
That's just where you leave it? Stop right
Yep, that'd be it. This is, this is it's because it's saying each function in terms of its cofunction. And this is the cofunction of sine, and this is what the angle is, complement of that one. Because it's always 90 minus it. So the sine is the cofunction of sine, or the cosine, and then 90 minus this is the complement. And then you simplify. All right? That's what you do with all those. The next group says find one solution for each equation. Assume that all angles in which an unknown appears are acute angles. Okay, let's look at 28. It says the cosine of theta equals the sine of 2 theta. Now, cosine and sine are cofunctions, right? So if I wrote this cosine theta and I wrote it in terms of the cofunction, I'd write the sine of 90 degrees minus theta, right? And that's true. But now, the sine of 90 degrees minus theta is equal to cosine. Cosine is equal to this. Therefore, 90 degrees minus theta is equal to 2 theta, right? Therefore, 90 degrees minus theta has to equal 2 theta. All right? Now then, we would solve for theta, and you would add theta to both sides. You'd have 90 degrees equals 3 theta, and then theta is going to equal 30 degrees. So you see that if you put this into the original problem, the cosine of 30 degrees is equal to the sine of 2 times 30, which is 60, right? And that's right. That's, these are not quite so intuitive. I'll do 30. Maybe I'll do 30. Secant of beta plus 10 degrees equals cosecant of 2 beta plus 20 degrees. Now, the way you figure this out is you say, well, if I had secant of beta plus 10 degrees, then I know its cofunction is cosecant and of the complement of this. And the complement of that is what? 90 degrees minus beta plus 10 degrees. And let's simplify that. This is going to be a negative, that's negative, so that's 80 degrees minus beta. But now what is true? 80 degrees minus beta has to equal 2 beta plus 20. Right? See, it's stating that this is true. This is by definition. This is true. Therefore, this has to equal that. So this is by definition. This is what the problem states is true. So therefore, I can conclude that 80 degrees minus beta must equal 2 beta plus 20 degrees. So then I put 3 beta over here, bring that over. That's going to be 50. And then I divide that out. Beta then has to equal 50 over 3. Is it 60? You're right. Sorry, 60. I can't add, subtract, multiply, divide. 20 degrees. So beta is 20. I thought that looks like it's going to turn out to be a pretty ugly number. So do you see what you're doing? You're just using the definition of cofunction to see what this is, and then you're saying this is what it's telling me it is. So then the two have to be equal. Any questions on that? If we look at 38, it says, tell whether this statement is true. Well, if you think about this, if tangent of an angle, and it's going to be related to sine of an angle over cosine, right? And if you have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, and cosine, and I'm going to have to go down here. Sine starts out at 0, goes 1/2, square root of 2 over 2, square root of 3 over 2, and 1, and cosine starts out at 1 and goes square root of 3 over 2, 1, square root of 2 over 2, 1/2, and 0. Now, what is happening to tangent? Tangent is starting out with this over this, then it goes this over this, this over this, this over this, this over this. What is it getting to here? Starting out here at 0, right? 0 over 1, and it's going to 1 over 0, which is infinity, right? So the larger the angle for tangent, the larger its value, right? So is this angle bigger than that angle? So this value must be what? Bigger than this one, shouldn't it? That's a true statement. It has to be true. All right, now the 40, if you notice, if you look at that hint underneath there, it'll help solving the problem. Here they have cosine of 28 degrees is less than sine of 28. And they're saying, rather than think of this as that particular kind of thing, think of the cofunction, the sine of 28 is equal to its cofunction, cosine, of what? 90 minus 28, the complement, which is equal to the cosine of, like 62, isn't it? Now, in other words, is cosine of 28 degrees less than the cosine of 62 degrees. Well, what do we find? What do we know? Cosine starts out at 1 and goes to 0, right? As it goes from 0 to 90 degrees. Remember this? Cosine starts out at 1, decreases down to 0. So the larger the angle, the smaller the cosine, right? Is that right? So if you look at this then, this angle is smaller than that angle, so the value of this should be what? Greater than that. So that's a false statement. And if you notice that all of those problems beyond 37 and 38 all involve, you can figure it out by using the cofunctions, right? Just by substituting, you know, cotangent of 30 degree, 42 says cotangent of 30 is less than tangent of 40. So just say what's the equivalent of tangent 40 in terms of its cofunction, which is cotangent. It's the cotangent of 90 minus 40 is 50 degrees. Then you say, all right, what's happening to the cotangent as the angle gets larger? Is the number getting smaller or bigger? You see that? That's what you do. Okay. Now the next group of problems, it says, for each expression, give the exact value. Well, we kind of went through those at the beginning. You can actually go back and use that table on 54. Now you'll have that table always in front of you, but for practical purposes, when you go out in real life, notice that all of those are the familiar angles, the 30, 45, and 60. And in practicalness, know your identities and know what sine and cosine are for 0, 30, 45, 60, and 90. And then you can, if you're, and what, the reason that those are important is because you can get an estimate of an answer. You know, if you're trying to work a problem, and if you're turning angles, and if the problem is, you know, okay. You know, always when you're solving problems, you know, if you got, you're trying to get an estimate before you do the problem. And if your problem involves, there's a tree on this side that you can reference off of, and you're going over here, and for our purposes, let's just say we can do right angles. You set your instrument up, you're able to get an angle, and probably you could do this. You could set your instrument up here, and then you take a reading on the angle. You take a reading over here, and then you just turn the angle down so that you get a 90-degree angle. So this is 90. Then you go over here and measure, you know, so many feet A. Set your instrument up here, and then turn the angle back here. And if this angle happened to be 27 degrees, And if you're trying to figure out what the distance was across here, then what relationship are you going to use? Opposite over adjacent, right? Tangent of that angle. You would know this angle, so you'd go tangent is equal to my unknown. It's actually tangent of 27. Is equal to my unknown. And then let's just say you had measured this as 20 feet over 20. Well, just for the purposes of getting an estimate, you can say, well, I'm just going to make sure that I'm close on my answer, I'm going to do the tangent of 30 degrees is equal to x over 20. Because you know what 30 is, right? Isn't that right? It's 1/2 over the square root of 3 over 2, which is the square root of 3 over 3, or something like that. Isn't that what it is? Is that right? So you say, well, square root of 3 over 3. So I know that 20 times the square root of 3 over 3 ought to give me, in my bulk part, right? I should be in that neighborhood, right? Then go ahead and solve your problem using your calculator. And then what would you want to do? You'd want to compare it back to this. And that's how come they're giving you those familiar ones, because you want to, you might be out in the field doing something, and you might say, well, when I thought about that thing out in the field, and you might want to write that down in your book if you didn't have, or something. Or, if you're putting numbers in the calculator and it automatically calculates it out, you might want to put this thing down and say, it's got to be close. And if it's just completely different, then you better go back and check, right? You better check whether your estimate was right or whether the actual problem solution was right. And I guess all I'm saying is that when you're out there doing actual problems, there's no answer book, right? And there's no teacher correcting it. It depends upon you being right. So what you want to do is you want to be able to calculate this in a lot of different ways. You want to get an estimate in your head, think, is it logical, do your calculations, and then have something else that you can reference. And if you can get about 3 of them to come pretty close, then you know you're right. That's why those standard angles are, because most of your problems you're going to be close to it. You can use that 30, 45, 60 as approximations. All right, I do have, for those of you that came in after I took the roll, the rest of you guys can leave. That's not good. Here, Dana, and then I got that homework. Did you guys, here, the other here was your homework, this is the news.
This test is on all of chapter 1.
Yeah.
What do we have for, what do you select with first?
We could have that. Okay, now you got both of the whole thing. That's the.
This is take home, this is chapter 2 take home, there's 2 things about that. Oh, you're pretty light on homework that first chapter. Last time.
When you told me, like, whenever the chapter.
Yeah, when chapter 2 is done.
Alright, sounds good.
And then your grade should be in WDP. And make sure that those are right, because that's where your grade for the course is going to be calculated. So make sure that the degrees are whatever.
Here, Tuesdays.
You bet.
If I email you in those with rest of 10, so I didn't realize how much I was there with the second half.
Okay.
The first half was all stuff I knew, the supplementary complement, and all
Yeah.
that stuff, but I didn't email Turtle.
I did. I keep forgetting to shut this off.